Welcome to my final presentation for the CIT260 course. My name is Ricardo Ledesma and I will guide you through my team's game design for the Joseph of Egypt game. This presentation will cover the following topics: static versus non-static variables and method, arrays and array lists and enums, for loops walking through an index, runtime error handling, the difference between characters and byte stream, and writing characters data to an external file. All these will include portion of our text-based game. And at the end, I will demonstrate how the games works. Static variables are also called class variables because they are constants and their value never change, no matter how many instances of the classes you have. So this is very handy because if there's something that you want to stay the same, no matter how many instances of the class you have, you will use static variables. Static variables are use reference that begins with the class name respective of the static variable, followed by a dot operator and then the variable name. Here's an example of some static variable we create in our main game class. We create the current game, player, and log files variable that will be available throughout the program for the entire game because there are only one game, one player, and log file at each time we call them because it is using the same location in memory. Non-static variables are also known as instance variables, and they have the capacity to change their value. Instance variable can have multiple copy allocated memory, which each object can be used and manipulate the property values regard its specific task within that function. A different feature from the static variable is that non-static variables require object instance before it can be used within a program. Those require object reference that begin with an object reference followed by a dot operator and the variable names. Here's some instance variables that we put in our map class that contain the numbers of rows, the numbers of columns, and with instance variable we refers to those using the keyword this. Here's an example of both static and non-static method in our code. The player, for example, here is created within a static method. The player variable is declared and instantiated, allowing it to be created only once, and it takes the name given by the user input at the beginning of the game and set it to the player. Arrays are a type of list, a fixed length list that contains either primitive values or object created from class. The elements in an array, however, must be or have the same data type. The elements in this list are referred by their index position. An example of an array is from our map class. We have an array of location. It is a two-dimensional array that holds those locations. We create a new array with the numbers of rows and the numbers of columns that will be passed into this function. Array list allowed us to create variable length list of objects. They can dynamically add and remove objects from that list at runtime. That object in the list might be of different data types. Enums allowed us to create fixed length constant list. An initial value or object must be assigned to every position in the list when creating an enum, and the elements in the enum are not referenced by an index. Instead, they are referenced by the name assigned to each element at the creation. So now let's talk about for statement and index. For each statement can be used to navigate throughout each element in an array. Here we have an example of using a basic for statement with index. For this example, we must use nested for in statements to navigate through all of the elements in an array. As you see, the outer for statement navigates through each row of the table. The index I in the outer for statement refers to the current row in the two-dimensional array. The nested init for statement iterate over each column in the column row in the current row. The index j in the inner for statement refers to the current column within the row. Okay, so here is the custom error handling, which is the way that we can handle the runtime errors in Java. We use the try and catch statement for catching error. This instance is the functions that we built to save our game. So we wrapped the game saving pieces within this try, and we catching exceptions, which is a high level. That should catch just about anything that could occur within the saving game. And if an exception is generated, it will be caught here. And then we throw in a new exception called game exception. But that is just to simply propagate the message from whatever exception occurred. Okay, now let's talk about byte stream and character stream. We use both of those when we build out the game. First, byte stream is the original class for reading in and reading out in Java. They read in and read out byte, one byte at a time, and they work within either binary bytes or ASCII encode bytes. They are handy and useful when reading and writing serializables objects to or from storage, which we did when we built the save function. But character stream are the newer class, and those should be used in most of cases because they work with Unicode character, which provides support for international characters. So probably we will use most often character stream. Now I'm going to show you how to write characters data to an external file. So let's go to our main game class. Here we're going to create a box file containing your file and I'll log a file. What I'm trying to accomplish here is to write errors into a log file. Here you can see the in the try statement, we open character stream for the end user input and output. You can see the buffer reader here and the print writer here. We also create a log files to whatever the error is going to be printed. Then we create an error view class. Here we create a class variable for the error file and assign it to our file. Then we create a function to display the error message. So if whenever this is an error message sent out, it's going to be pushed the error and printed into the log file. So now let's show how the program works. Okay, here we have our game. I'm going to use two words to assign it, and it says as AS. We hope you enjoyed the game, and it's the message. We have our menu here. So let's first see the help menu, which is here. It says what's the goal of the game. It says the goal here, and we can see most of the things. For example, we can see how to view the map game. It's throw us an error because we use letter instead numbers, and it says that it's about selections. Okay, I'm gonna select 3, and it says how to do this. So I'm gonna return to our game, and I'm gonna start a new game. Okay, here we have, and I'm gonna manage prep, and it says give us the welcome to the office, and it says how many width and how many acres we have. So it's ask us the first question. I'm gonna use 100. I'm gonna buy 100 acres of land, and because of that, I will need to use 19 bushels of wheat per acres. Now I'm going to say how many lands. I will say I don't want to sell anyone. And I have available only one, which is a bad star. I only have 900 bushels of wheat. I'm gonna use maybe 15 to feed the people. So it's time to plant. I will use 400 to plant, and it says, I'm sorry, sir, you can do this. I can have, I don't have enough worker to do this. So I'm gonna use 20 to plant. And it's time to plant, and it says that is successful. So this is the presentation for the game. I hope that could be understood, and I'm so grateful for being part of this class.